Hey everyone! All right, so I have a whiteboard, I have a marker, and I'm going to do a little quick review. These are problems that you should feel pretty good about because we've done them before. The instructions are pretty clear. They say, which is greater? So we're going to be given two things, and we have to compare them and look for the bigger of the two. So these are fractions. So, would you rather have 1/4 or 1/8? So you have to imagine the same thing being cut up. 4 medium-sized pieces or 8 small pieces of pizza. Would you rather have 1 medium piece or 1 small piece? Yeah. 1 medium piece is greater. So even though it's a 4 and this is an 8, that doesn't mean how big it is. It just means how many cuts the whole pie has been divided into, right? So if I was to show you 1/4, you would see that it is a nice medium-sized piece of pizza. Whereas if I was to show you 1/8, those are fourths. These are eighths, much smaller size of pizza. See? So without doing the model here, would you rather have 1 medium-sized slice of pizza or would you rather have 1 huge slice of pizza? That's going to be the greater number. Half the pizza is huge. That's half a pizza. Whereas if you look at this one, oh man, I don't even know if I can cut it into 5 pieces. No, that's 6 pieces. Well, one of these would be about the same size as a 1/6. I mean, about, right? Anyway, you can see in relative terms that 1/2 is way bigger than 1/5 or 1/6. My terrible drawing here. 2/3 or 3/3. Now, this is a little different. So, 2/3 means I have most of something. I have 2/3 of it. 3/3 mean I have all the pieces to something. So all the pieces is going to be more than most of the pieces. Yeah. And then would you rather have 4/5 of a pizza or would you rather have a whole pizza? The whole is more than 4/5. So we're just thinking back to last chapter when we were doing fractions and which fractions are greater. The temptation with some of these is to pick the bigger denominators as greater, and I just wanted to show you that that's not the case. Bigger denominators just mean smaller pieces. All right, so this friend of ours, Katie, she's taking a test, and each problem on the test is worth 2 points. Katie gets 5 problems correct. What's her score? So I'm going to give myself a little bit more room to do this. So let me just kind of group these and scoot them out of the way. Forgive me here. Okay. So she gets 5 problems correct. So she gets 1 problem correct. And then she gets another problem correct. 3 correct answers. 4 correct answers. Oh, here's her 5th correct answer. Now, you could, if you wanted, add up 2 and then plus 2 and then plus 2 and plus another 2 and plus another 2. This is called repeated addition when something happens over and over again. But lots of people don't like writing all those 2's. So instead, they would say, I have 5 2's, right? And they would just hold up 5 fingers and they would go 2, 4, 6, 8, 10. And they would skip count to get the answer. In this case, it's a product if I'm multiplying, or a sum if I'm adding, but same answer either way. Repeated addition, multiplication. Okay, these should be things, oh yeah, I remember doing the 2's and 5's and 10's back a few chapters ago. Thank you for reviewing with me, everybody. Thanks now.